easy to do, but now we're actually going to start into rational functions. And a rational function means that we actually have a fraction where x is going to be on a denominator somewhere. So notice here, I've got a rational function. And we briefly touched on at the beginning of the year rational functions, but we talked about them with where the domain is restricted. So raise your hand if you can tell me where f of x is restricted. Justin. Okay, so the denominator where x is on the bottom. So what do I have to do with that bottom? Good. So I'm going to set this, oops, there we go. I'm going to set this not equal to 0. So x cannot equal 1. Does that make sense? Okay, so I'm going to do the same thing over here. It's the exact same type of problem. Not equal to 0. I'll add 1. So x squared cannot equal 1. And I'll take this square root. Uh-oh. Justin? Good. X is not equal to plus or minus 1. So here it's restricted twice, where here in the first one it's only restricted once. That actually helps us when we're talking about the vertical asymptote. And we'll be seeing that here in a minute. But a graph actually has a vertical asymptote, sorry. I told Mr. Williams I'd say it correctly this year. Vertical asymptote at those spots. So those are where the graph has the vertical asymptote. At x equals 1 and x equals plus or minus 1. Meaning the graph gets really close, but never touches at those spots. Okay? So we actually have a few different asymptotes that we have to talk about. We have a vertical asymptote. We have a horizontal asymptote. We have a slant asymptote. And we have what's called a hole. And I'll show you what that is here in a minute. But I'm going to give you a second to finish copying that down since some of you are latecomers. So in order to graph a rational function, you actually have to find a few things. One of the things you have to find is a horizontal asymptote. And there's rules to follow. Like if your degree of your numerator is higher, there's none. There's no horizontal line. But if your degree of your denominator is higher than its y equals 0, if they're the same, then you make a ratio of the leading coefficients. And then you have a slant asymptote if the degree of the numerator is exactly one more than the degree of the denominator. So an example of that would be like x cubed plus 3 over x squared plus 4. Notice how it's exactly one more, 2 and 3, right? If it's 2 more, then there's no slant asymptote. If the denominator is bigger, there's no slant asymptote. Now, if you remember, I really made you do long division for a while, didn't I? And it wasn't because I thought, okay, this is fun, let's do long division. I promise you that was not the reason. It's because now, if you find you have a slant asymptote, the only way to find it is to do long division. You can't just use synthetic division or something like that. We actually have to do that long division. So, another thing we need to write down is graphing rational functions, there are steps and things you have to do. You have to determine the horizontal and slant asymptotes, determine holes, determine vertical asymptotes, find x-intercepts, find the y-intercepts, plot a few additional points, and then draw the graph. I know, lots of stuff, right? All right, so we just talked about what jojoba was, and it's actually a way to help us to remember what to do first, what to do second, what to do third. So we find horizontal asymptotes first, holes second, and then we'll find vertical asymptotes. So it's going to be easiest if we actually just start from the beginning with here's a graph. And so what you're going to do right now is to copy down that problem, stick in a piece of graph paper, but make sure there is room to do work beside that graph paper. Meaning if you're near the end and there's no room, you're probably going to need to go to the next page. All right, so right now you should be finding the horizontal asymptote because jojoba tells us that's what we do first. So I'm going to write HA for horizontal asymptote. Okay, I said HA. There we go. And what you have to do is you have to look at the degrees of the numerator, degree of the denominator. What is the degree of this numerator right now? 0. There's no x up there, it's a 0. What's the highest degree in the denominator? 1. So notice here the degree of the denominator is bigger. So what is the horizontal asymptote according to the rule? What? Y equals 0. So I'm going to write that y equals 0. What is the degree of the numerator? Is there an x up there?
Yeah.
Okay, no. What's the degree of the denominator? What's the exponent on the x? What is? There it is. No x, so it's a 0. 1x, so it's a 1. If it had been this way instead, x squared plus 3x over x cubed, the degree would be 2, and the degree would be? Does that make sense? Highest degree. Highest degree. Because you're looking at the degree, which means the highest exponent. Not all of them put together, the highest exponent. Does that make sense so far? Okay. The next thing you do is you factor the top and bottom if you can. Well, can you factor any of that? No. So the next thing you do is you look for holes. In order for a graph to have holes, that means a factor in the top has to be the same as a factor in the bottom. So let me give you an example that has holes just so you can see it. X plus 3 over x plus 3, x minus 3. See how x plus 3 is on top and bottom? Then that would have a hole at x equals negative 3. If I set that equal to 0, there'd be a hole right there, right? Okay, so that's how you know you have a hole. If the top and the bottom have the same factor. Do I have a hole in this one? No, I don't. I don't. If I have the same thing in the top and bottom, same factor, then there's a hole right there. Meaning I just set that piece equal to 0, and that would be my hole. Okay? And we'll see one here in a little bit that has a hole. But I want to go over all those pieces with you as we're going through this example problem that's actually a lot easier than most problems. So holes, guess what we get to write?
0.
Not 0.
1.
None. I don't want you to write 0 because that's a number, right? So then I'm thinking, okay, I put a hole right here, 0, 0. No. I want to write the word none. Okay, vertical asymptote. You've actually been doing vertical asymptote. Every time you find a domain, you're finding the vertical asymptote. What can you not have in this denominator? Negative 3, right? Does that make sense? So right here, my vertical asymptote is x equals 3. My domain, on the other hand, is x is not equal to 3. And I'm going to explain that here in just a second a little bit more in depth. So the vertical asymptote is a line that the graph gets really close to, but never touches. Meaning it can never physically touch 3. Yeah. Oh, negative 3. Okay. Good call. Good call. That's okay. That's all right. But it gets really close to negative 3, but never actually touches it. And that's why we say it's not equal to negative 3 there. Yes. Yes. Okay. Well, before we go any further, let's actually graph these two pieces. So I'm going to graph my horizontal asymptote, y equals 0. And what you do is you make a dotted line going the entire way across at y equals 0. And that's got to be horizontal because it's a horizontal asymptote. Look, I've already flipped back to that. What else do you think I'm going to put on there? The vertical asymptote at negative 3, right? Yes, always put your asymptotes on as dotted lines. Regular lines are part of the graph. Dotted lines are just helping us to guide the graph. Okay, so I told you need to do jojoba. What was the next thing you had to do according to the last slide? X-intercept, right? Okay, in order to find x-intercept, all you do is set the top equal to 0. Set the top equal to 0. Uh-oh, is there an x in the top of this one? So guess what? There's no x-intercept. Also notice, here's my x-axis. It's an asymptote line, right? So could I actually ever get on this line? No. So that's also a reason why there's no x-intercept. So in this case, there's none. Any questions so far? What else do we have to find? Y-intercept. These are my favorite. Okay, when I tell you something's my favorite, it's usually because it's easy, right? Not even plug 0 in for x. Plug 0 in for x. Well, it's not 3. It's 1/3, right? So I get 0, 1/3. I plug it into the entire function, not just the bottom, but the entire thing. Nope, I gotta do both. When I'm plugging it in, I'm plugging it into the entire function. Well, now I get to graph that point. 0, 1/3, that's about right there. Between 0 and 1, right? And what does the last step say? Plug in some additional points. So I'm going to make a little chart. Kind of ran out of room right there. What points do you want to plug in? Brandon. What?
1 and 2.
Well, here's the thing. See how close I'm already getting to that line? My guess is that it's going to get even closer to that line. So I actually want to pick, how about -1 and -2? Because I want to get closer to that line. What else do I need to pick? Well, I don't need to pick 0. Because you already have 0. Okay, what? Well, if I pick -3, will I get anything on this line? No, so -3 is not helpful. -4. I'm going to pick 2 points on the other side of the line to help me. So -4, and then the one right after it, -5. So I'm picking points close to the line to help me. Close to the vertical asymptote to help me. Well, I've got 4 of them, and I've got 4 groups here. So, group number 1, plug in -1. Group number 2, back there, plug in -2. You guys plug in -3, and you guys have, you guys have -4, you guys have -5. Go ahead and plug in your corresponding number. And then check up here and see if your number is correct, and then you can fill in the other 3. You guys understand how we're plugging the numbers in? Okay, if you need to, you can use a calculator, but I would probably say for this problem you'd mess up more than you would do right using the calculator. So just use your head. So now I'm going to plot those. -1, 1/2, and then -2, 1. If I plug in -2.5, by the way, I'm going to get even closer to this line. If I plug in -2.99999, I'm going to get really close to this line. Does that make sense? So instead of making you plug those numbers in, though, we're just going to know that they get really close. So now I'm going to draw my graph for this half.
How come we don't start on our dotted line?
Because that dotted line is where you get really close to, but never touch. You did exponential graph and logarithmic graph last year, which are similar because they do have asymptotes. Okay, let's graph this side. If I go to -4, I go down to -1, and if I go to -5, I go to -1/2. You think you can draw that half of the graph in already? I think you can. Go ahead. There's my lovely graph. So normally, just so you know, if it's broken up into 4 pieces, either it'll be here and here, or it'll be here and here. Or it'll be here and here, here and here. Meaning you're not going to have one on top of the other. Does that make sense? Okay. All right. Let's try another one. So again, we're going through all of our pieces. All right. So far I had you find the domain. And you told me x does not equal -1. I'm sorry, x does not equal -1. So now we're talking about the horizontal asymptote. And since this part's different, that's why I started again. Okay, I noticed the degree at the top and the bottom are the same, right? So what's the next thing I'm supposed to do if they're the same according to you? Find the ratio of the leading coefficients. Now, just because 3 and 1 are in front does not mean they're leading. What number's in front of the highest exponent variable? 2 and 1, right? So we're going to write y equals 2, because 2 divided by 1 is 2. That make sense?
So, like, okay, wait, 3 plus 4x over 1 plus 2x equals 4.
Yes, which is? Yes. So technically you should always put it in standard form, is what it's telling you. It makes it easy.
So what the leading coefficient is in the name
No,
of
if the, yes,
Okay.
yes. Okay, what's the second thing I find? Oh! Okay, can you factor anything in the top or bottom? No? So guess what? None. Vertical asymptote. Okay, since Cheyenne did domain, the vertical asymptote should be nice and easy, right? X equals -1. Okay, draw those 2 lines on your graph. Make sure they must be dotted lines. And just so you know, if you're the type of person that likes to use colored pencils or different things, if you want to make your horizontal and vertical asymptotes a certain color, that's cool with me. I like that. Okay, what's after that? X-intercept. How do I find x-intercept? Set top equal to 0. So that'd be 3 plus 2x equals 0. Set top equal to 0. You've already set the bottom equal to 0. So the x-intercepts are the top. X equals negative, how about 3 over 2? Negative 3 over 2. So I'm going to write that as an ordered pair. Negative 3 over 2, comma 0. X-intercept means it touches the x-axis, but it's 0 on the y. So where is negative 3/2, by the way? Negative 1.5? So between there, negative 1 and negative 2? Ah, so I know now immediately, part of my graph is here. Isn't that right? Okay, what else do I need to do? Y-intercept. How do I do that? Plug 0 into x, okay. Y in. 3, oh, that's 0. So 3 over 1. So I get 0 comma 3. okay. She's thinking, that's a good thing. So I'm gonna plot that point, 0, 3. I put 0 in for x. Well, 2, I didn't realize I didn't need that 2, so I just put 3 plus, and technically it'd be 0.
Why are you
And
putting
1.
the 0? Why don't you wait and choose your x-intercept and then do your y and then negative 3 or negative 2?
Because notice my x-intercept has to be on my x-axis. My y-intercept has to be on my y-axis. They're not one single point put together. They're 2 separate points.
So there's always going to be a 0.
Yes, there's always going to be a 0 with it. Now this actually is a nice graph. Because already I can tell half my graph here and half my graph is here. Right? So remember how on the last one I plugged in like 4 points? I don't need 4 points this time. Because I already have 1 here and 1 here. So I probably need 1 more here and 1 more here. So what numbers do you want me to plug in? -4 and 4. Okay. Do yourself a favor. Don't ever go that far from the vertical asymptote. Stick close. So try again. Well, if you plug in 0, 1 and -3? Okay. 1, because that would be the next one over. And -3 or -2, either way would work for me, because that's pretty still close to this. I try to go what is next in consecutive order. So I'm going to plug in 1. 5 over 2. So I plug in -3. -3 over -2, which is 3 over 2. Okay, so at -3, I'm at 1.5. And at 1, I'm at 5 halves, so it's 2.5. Hey! There's my beautiful graph. So what I did was I plotted those 2 points, and I could then tell it's going to go. Does that help? It's never going to be something weird that's like out here, like circling around or something. It's going to get close to those 2 lines. Okay? How do you feel with that? Oh, on the top I have 1, 5 halves. And I have 0, 3. Good question. You get 1? So that would also work, right? Oh, if I plug in -2? Yep. So, honestly, it's a lot of steps to follow, right? And obviously, we're not going to get through all of our notes today, but we are going to stick another one in. I'm going to give you the homework. I'm going to make it due Monday. So you can make another page of notes. That's fine. Yep. Oh, absolutely. So I'll give you a minute to go ahead and write that one down.